Hey everybody. We're continuing to try to get rectangles drawing on the screen, and the next step in our process is to make a vertex shader. So again, like everything else so far, we go back to our device, create vertex shader. Go look up the parameters, and we see the first is a const-word function, and then the return value of the shader. So not quite sure what that is at the moment. And then the return value of the vertex shader. Okay, let's go into this a little bit more. So this first parameter is actually basically the bits representing the compiled vertex shader program. You can either make those bits by writing them by hand, potentially, loading them from somewhere else, copying from somewhere else, or assembling a shader from shader assembly, or compiling a shader from HLSL, high-level shader language. We're going to do that. We're going to compile the shader, not just compile a shader, we're going to compile a shader from a file. So fortunately, there's a little helper function to go ahead and open the file and do all the file stuff for us. So we're going to just use that for a second. Eventually, we'll make a resource system that manages the file system for us. But for now, we can open the file directly. So first is a source file. Let's go ahead and make a new source file. New text file. Gonna go ahead and make that big enough to see. And we'll call it fill2d.shader. And we'll save. Save it as shader file. And there we go. Cool. Got our shader file. Where is that? That's up from the debug directory into the code directory into the file. Next, here is a set of parameters that represent. So we're basically calling a compiler right now, and just like the C++ compiler, you can pre-include or predefine. We could do that too, and we're not going to. But that might be useful if we're like, oh, we want to compile for be debug, and then if debug, we set a compile flag and we can get different shader outputs. For right now, we're not going to specify any preprocessory type things. Next is the function name for this shader, and since this is the vertex shader, I always call my vertex shaders VS, and I put them in the same directory as the pixel shader. See why for that in a bit. Then the next is kind of a versioning string. This, I assume, started at VS 1.0. I think they're up to 4.0, and but I'm not an expert, but I think 3 and 4 are tied to DirectX 10 and 11, so we're kind of stuck on 2, and I think you can get away with 2.5 in some cases, but we're going to stick with shader model 2 for now. Some flags. And this looks like it sets there's probably a handful, but at parsing, the one they list here is the overriding the matrix order, which we don't care about. And then we have our out params. We return a shader. And so that's an ID3D. That it returns a D3DX buffer. Shader data. There. And then there's a buffer for errors, which is useful to help debugging when we have errors in our shader files, and then a constant table. And our first one isn't going to have any constants in it, but just so we get used to doing this. There we go. So in theory, we have buffer, we have an error buffer, we have constants all set into this function. If we failed, we're going to go ahead and trace the error output. And this DirectX buffer, or DX buffer, has a get buffer pointer. This gets the data in that buffer. This comes out as a void star, so we'll cast it to. Okay. Then vertex shader, we'll take the shader data. I'm just going to put a breakpoint here. We can always just break if we ever get an error. Shader data, get buffer pointer. And again, it took that D word pointer. And then release, and then release, because we're not going to use it. Oh, yeah. Okay. Then you'll notice these are on these D3DX. So this is a set of extra tool type functions you might not want in the main game. And we'll go ahead and include the appropriate include to make that work. We need the D3D9 shade X shader file, and then the D3DX9 lib. Put it in there, and this is in. If you have the default Visual Studio install, you probably won't have this. You probably need to go get the DirectX SDK. I have the DirectX SDK here, so I'll take that and put that into my include directory of my project. Put the include directory here, put the library directory here, same place except it's lib/x86. Cool. Now we should get all our squigglies to go away. Then we need to output this trace thing, and here I've written a little function that takes a string and outputs the debug string. This will output print to your trace window when you call it. So we have a trace function, and we should hopefully get something. Let's compile, make sure we got all the, fix our little compile errors. And there, okay, open our shader, get an error. We've got errors. We go and trace the error. Trace error shows up, and it says, entry point not found. So we made this file is empty. We need to actually write a vertex shader. What's a vertex shader? Well, a vertex shader is just some code that describes what you want to do with your pixels, your vertices that come through this pipeline. So we need to write a function, and this is written in a totally different but C-like language that outputs vertices. And so the typical thing you'll do is for the vertex shader, you'll take some vertex shader input, you'll turn it into some vertex shader output, you'll define these two structs, and write a little function in shader language. And shader language is kind of like C, but a little different. So our input, what are we sending into our vertex shader? Well, we've already actually set that up. Our vertex declaration down here is what we're sending. A little too far, overshot. Is what we're sending into our vertex shader. We're sending a float 4 called position, and then a float 4 called color. So we need a float 4, we might as well use the same name, of semantic position. And then we need a float for a color of, which is a color. What are we doing with that? Well, I know already. We're going to take that and make an output, and it's going to have, yep, position and color. And really, this is a really simple shader. It's just copying. We're not doing any multiplication. We're not doing any transforms. This is like the most brain dead shader you could probably ever write for this type of thing. We're just copying the position from the input stream to the output stream. Save that. Go ahead, run our game again. Hopefully get a good breakpoint. Failed. Not all control paths return a value. I forgot to return the output, but otherwise it's pretty good. And sweet, we created a vertex shader successfully. HRS okay. We have a shader data, and we're going to go ahead and set that shader data, get the buffer, set it, create that shader, take that compiled vertex shader and create an vertex shader instance from it. Great, got one okay. Then we're going to take that compiled vertex shader and go ahead and set it. And of course, release it. Put some breakpoints, check all that stuff out, make sure everything's okay, release our shader data and our constant things, because there's, if we had put some constants in here, we'd have to fill them in. We didn't use any constants. We're making the brain deadest shader ever. Easy. So fall through, set the shader. That's okay. So we've hopefully successfully created a vertex shader. We've set it. We've compiled it from our shader file. And we're almost there. We just need to make our pixel shader and call our draw call, and we'll have, hopefully, a rectangle on screen. Check out the next video to see if it turns out that easy.